Hi student, today our topic is relation and function chapter 2 class 11. So relation and function have a very important role in our day-to-day life. We can see many relation in our life like brother, sister and mother, father and teacher, students. They all are the different kind of relation and many more relation we can explain in our day-to-day life. So in other word we can say a relation having an input having many output, but in a function we can see only one output of a input relation. For example, if we are buying any ticket, lottery ticket, so we can have many prizes for that. Or in a function, if we can see the height of any person at a particular age is fixed. That is called a function. So there are many more examples you can take in our day-to-day life of relation and function. Now we will come to the exercise of relation and function. So before going to the further, we should know the order pair. Order pair. What are order pair? Order pair is like A comma B, 1 comma 2. Here we have two values or two elements represented in a open bracket. So this is our first element and second element, and this we call an order pair. So for order pair we can see the topic equality of order pair. Equality of order pair. What is the equality of order pair? We can see if we have two ordered pair, if two ordered pairs like A1 B1 and A2 B2 are equal if and only if A1 is equal to A2 and B1 is equal to B2. It means if we have any two order pair, they can only be equal if the first element of this pair is equal to the first element of this pair, right? A1 B1 cannot be equal to B2 A2, right? So we can take one example for this. Like we can take one example, find the value of A and B. If 3A minus 2 comma B plus 3 equals to 2A minus 1 comma 3. So we can see here if two order pair need to be equal, for that the first element should be equal to the first element of order pair. So we can write it like this: 3A minus 2 equals to 2A minus 1. From here we can see we can carry 2A this side and minus 1 to this side. So it will be A equals to 1, right? And here we can equate the second element B plus 3 with 3. So here we can see the value of B is 3. So this is how we can see the equality of a two order pair. Now we will come to the next topic, the Cartesian product. So Cartesian product. In Cartesian product, what we can see? In this we can say if we have two non-empty set A and B, right? Then there exists Cartesian, then the Cartesian product of product of A cross B is the set of all ordered pair of elements from A and B, right? So here we can take one example. So like for example, you can see if we have one set A 3, 4 and another set B is like A, B, C. So here we can find the Cartesian product. So in the Cartesian product we can see the relationship between the elements of set A with the element of set B. So we can form the order pair. First from 3 we can see 3, A, 3, B, 3, C, and with 4 we can form the relation 4, A, 4, B and 4, C. So this is how you can form the relationship or between the A and B by the Cartesian product. So in this we need to know the more things, like if we want to find the number of element in A cross B, so you can see if we have element in A is A, B, and in B we have in A cross B, we can see the number of order pair is 1, 2, 3, 4, 5 and 6 order pair. If we want to find the number of order pair in A cross B, for that we have a formula of Na into Nb. I am taking two sets here, A having element A and B and B having element C and D. So we can see number of element in A is 2 and number of element in B is also 2. This will be 2 to the 4. Or in this example, you can see the number of element is A is 2 and number of element in B is 3. So we can, if we can multiply by this, 2 multiply 3, we can see the 6 order pair, 1, 2, 3, 4, 5, 6, right? So this is how we can show the Cartesian product. Now we will come to the next topic. In the topic, we can see what we can see. If we have any two sets A and B, right? If we have any two sets, if we have any two sets A and B, in that we can see if one set A has infinite number of element and we have any elements like 1, 2, 3. So in the Cartesian product they will have infinite relation, right? If A and B, if any one of the set have empty set, then the Cartesian product will have empty relation, empty order pair. Now we will come to the next topic. That is, the next topic is scalar, the triple product of any set. So in this we can see if we have any set A, if we want to find the Cartesian product of this set with 3 times, so we can say that we can take one example here. If we have A, B, C element in any set, such that A comma B comma C containing A. So then A, B, C is called an ordered triplet. Ordered triplet. So here we can take one example, like for example, if we have any set like A having element 2, 4. So if we want to find the triple product A cross A cross A, so for that first we will find the cross product of Cartesian product of A into A. This will be like 2, 4 and 2, 4. So we can say we can form the order pair with this 2, 2 and 2, 4 and with 4, 2 and 4, 4. Right? Now again we will multiply A with A. So we can see here we need to multiply this by 2, 2, 2, 4, 4, 2 and 4, 4 with 2, 4. So here we can form the order pair of this. We can see if we multiply 2 by 2 by these two elements, we will have the element 2, 2, 2 and 2, 2, 4. And by this we can see 2, 4, 2, 2, 4, 4. And by this we can see 4, 2, 2, 4, 2, 4. And by this you can see 4, 4, 2 and 4, 4, 4. So this is how we will find the Cartesian product of any set with 3 times. Now we will come to the next topic. The next topic is relation. So here we can see now the topic is relation. What is a relation? A relation R from a non-empty set A set A having some element is called non-empty set, and to a non-empty set B is a subset of all the Cartesian product of A cross B. The Cartesian product you have seen, if we have taken the two non-empty set and we form the order pair, that order pair actually called the subset of that relationship. Now we can see the subset is derived by describing a relationship between the first element and the second element of the order pair in A cross B, right? So the second element is always called the image of the first element. For this I am taking one example. For example, if we have any two set like 1, 2 and B having element A, B, so we can form the relationship between them by A cross B, the Cartesian product. So we can see if we multiply A by B, we will form the order pair 1, A, 1, B and 2, A and 2, B. So these all are the possible relationship between the elements of A with the elements of B. So here we can see the number of element in A is 2 and number of element in B is also 2. So number of element in A cross B is 2, 2 multiply 2 is 4. If we want to find the subset, for subset we have a formula of subset, that is, we are aware of that the subset of any relationship is 2, the power of 2 is p into q. So here p and q are the actually the elements of the given set. Here we can see, if you want to find the subset of this, so the subset of these two sets will be the element of in a A is 2 and element of in a B is also 2. So here we can see, if you want to find the subset of this Cartesian product, the subset will contain the element 2 to the 4 is 16. So if you want to find the subset of this A cross B, that will be a 16 element in order pair, right? Now we will come to the next topic. The next topic is how to find the domain range and codomain. So for that I am taking one relation in the form of arrow diagram. If we have any set A having element 1, 2, 3, 4 and another it having a relationship with B like A, B, C, D, E. So here we can see the relationship. We will form the 1 with A and 2 with C and 3 with B and 4 with D. So here we can form the relation is 1 comma A, 2 comma C, 3 comma B and 4 comma D. So here we need to find the domain, range and codomain. What are domain? Actually, domain are the element of the relation. First element of the relation is called the domain. That is 1, 2, 3 and 4. Right? And range actually the second element of the relation. That is, we can say A, B, C, B and D. This is our range. And what is the codomain? Codomain actually all the elements of a set V, that is A, B, C, D, E. Here we can take the element which does not have any pre-image in domain, right? So you can also say the range is the equal subset of codomain, right? You can easily say that all the elements of a range are containing in the codomain element. So that's why we can say the range is the equal subset of a codomain, right? Here, one more thing I want to clear here, key 1 is having an image. These elements are called the image of these elements, and we can say A is having a pre-image and the element of domain is called the pre-image, right? So this is the important topic. You need to clear that domain, range and codomain. It is actually the relationship between the element of set A with the element of set B. In this we can see in the relation we can see the element of set A is called domain and the set element of set B in a relation is called the range, and the codomain, all the element of set B is called the codomain. And by this we can say the range actually is the equal subset of a codomain. Right? Now we can come to the next topic. Next topic is function. The topic is function. Now we can see the function. What is a function? Very important topic. We can have a very important uses of this topic in our math, that is function. Actually, a relation from a set A to a set B is said to be a function if every element of a set A has one and only one image in a set B. For example, I am taking one example, like if we have element 1, 2, 3 in a set A, and in a set B we have an element like A, B, C. So if we have a relation of 1 with A, 2 with B, and 3 with C. So here we can see that every element of a set A has an image in a set B. So that's why this relation is called a function. I am taking some more example to clarify this. If we have any set, like we can say 5, 7, 8, and here you can see P, Q, R. So here if you can see, if we have image of 5 is P and image of 5 is one more image is Q, and 7 is having image R. So here we can see the element of set A, 5, have a 2 image in a B. So that's why we will say that this relation is not a function. It is a function because by the definition we can see the every element of set A should have only one image in a set B. But in this we can see the element 5 has a 2 image. That's why it is not a function. One more example we can take here, like 1, 2, 3, A, B, and C. If we can see in this relation, we can see the 1 having image A, and 2 is having image A, and 3 is having image A. So here this relation is called a function because every element of a set A has a unique image, a single image, right? That's why this relation is called a function, right? Now we will come to the next topic, the real value function. The real value function. Now we can see the real value function. A real value function. What is real value function? And the function which has either R on the subset in its range. If you can see in the range, if all the elements are real number, then we said the function is real value function, right? Or in more, we can see if domain also a real number, then the function is called real function, right? Now we come to the types of function. Types of function. So in types of function we can see the first type of function is identity function, right? Identity function is like y equal to x. The graph of this function is like a straight line. In this we can see for the value of x, the value of y is also same. So this type of function is called identity function. In that we can see both the values are equal. For value of x, for any value of x, the value of y is also equal. And the second type of function is called constant function. In constant function, you can see the function is like y equals to c. Here you can see for any value of x, this is x axis and this is y axis, this is x axis and this is y axis. For every value of x, the value of y is fixed. So this is our constant function, right? Now we come to the next type of function. The next type of function is polynomial function. You are well aware of the polynomial, right? The polynomial can be linear, quadratic, cubic. So the next type is polynomial function. Polynomial function. So we can take one example like 3x square minus 2x plus 4. So we are well aware of that. The polynomial function is always have a parabolic shape. Like this is called parabola, which we will study in our further chapter in conic section. So this is a parabola, right? Now we come to the next type of function, that is modulus function, right? Modulus function is like if we have a function like y equal to mod x. So here we can write this function y equal to fx is like it will have a value x for every value of x greater than 0 and 0 if x is 0 and minus x if x is less than 0. So you can show the modulus function like this, and for the graph of this function will be like this, because we can represent this like a y equal to plus minus x. For the plus value, we will get the line on this quadrant, and for y equal to x, we will get this line. For y equal to minus x, we will get this line. So this is the graph of our modulus function. Now the next type of function is signum function. One more thing, if you want to find the domain, if we have asked what is the domain of this function, for the domain of this function, domain actually the values of x. So here we can put any real number from minus infinity to plus infinity, and the range. What is the range? Range is the value of y when we are putting the value of x. So in the range we can have only positive value, because if we will put any real number here, we will always get a positive value. So you can write the range here is all the real number except negative real number, right? So this is the range of this modulus function. Now what is the signum function? What is the signum function? Signum function, again, they all relation are from R to R relation, real values relation. So here if function is R to R, so the signum function is fx equals to 1 for every value of x greater than 0, 0 for the value of x equal to 0, and minus 1 for value of x is less than 0. So here we can show the graph of this function. For the graph, we can see here for the graph of signum function, we can see the graph of this signal function x and y. Here we can see for every value which is of x which is greater than 0, the value of this function is 1. So you can show it like this, right? For every value on x like 1, 2, 3 and so on, we will always get a value 1. And for 0, we will get the value 0, right? And for the value of x less than 0, we will always get a minus 1 for any value of x, minus 1, minus 2, minus 3. So this is the graph of our signum function, right? Now the last type of function is greatest integer function. Greatest integer function. What is greatest integer function? So in greatest integer function is the function from R to R, real number to real number. We have the function like fx equals to this is a closed bracket. So in this we can see the values like if we have values of mod x is minus 1 for x is greater than equals to minus 1 but less than 0 and 0 for x is greater than equal to 0 but less than 1 and 1 for x, the value of x is greater than 1 but less than 2 and 2 for value of x is greater than equal to 2 but less than 3. So here actually the greatest integer function you can see for this value if we have any value like 1.2, 1.3, 1.4. So we have a greatest integer value. Here the greatest integer value is 1. So like this, if we have any value like 2.1 and 2.1, 2.2, 2.9. So here we can see the greatest integer value for all these will be 2. So on graph we can represent it like we have the value x and y. So here we can see 1, 2, 3, 1, 2, 3. So here we can see the graph of this. In the graph of this, we can see the value for the value which is 0 to 1. For 0 to 1, the value of greatest integer function is 1. And from 1 to 2, the value of function will be 1. And from 2 to 3, the value of greatest integer function is 2. Now, same with the value minus 1, minus 2 and minus 3, minus 1, minus 2 and minus 3. From here we can see the value for the function minus 1 to 0, minus 1 to 0, and here we can see the minus 2 to minus 1 is minus 1. So this is how we can show the greatest integer function, right? Now the last topic of this chapter. Now the question, it is very important question. You can see in your examination. If fx equals to 9 minus x square, then find the domain and range. Actually, the domain is the value of 9 minus x square. Here we can see for domain, for domain 9 minus x square is always greater than equal to 0, because in square root the value cannot be negative, because negative value is not a real value. So this is defined, the function is always defined for the real values. So here we can see minus x square is greater than equals to minus 9. So this will be like x square. If we will cancel out, the equality will change. So here you can say the value of x is greater than equals to minus 3 and less than equals to 3. So for this relation, where here x square is greater than equals to minus 3, so here x can be minus 3 to 3. So here you can say the domain is equal to minus 3 to 3. Right? This is the value of domain. And for range, one thing we need to clear is that if the value of fx is cannot be negative value. So if we are putting any value from domain, because domain is the value of x, if we are putting value minus 3 to 3, we will always get a positive real number. So right, so it means you can clear the thing, it cannot be negative, right? So now here we can see the fx is actually equal to y. So you can write y equals to under root 9 minus x square. Now you can do the squaring both sides. Y square equal to 9 minus x square. Here you can find the value of x square equals to 9 minus y square, or x equals to plus minus under root 9 minus y square. So here you can easily see the value of, so 9 minus y square is always greater than equals to 0, because it cannot be negative. So again, y square is greater than equals to minus 9, the y square is less than equals to 9. So here the value of y is also minus 3 to plus 3. So the range, so here we can clear that the range cannot be, because value of y is actually a range, the value of range, that is fx. So the value of y cannot be negative. So that's why the range for this function is from 0 to 3. So this is all about this chapter, and we have discussed all the important topic of this chapter. Thank you.